The z-table usage. The probability of areas under the curve is always 1. For the actual value, one can identify the z-score by using the z-table. Now the z-table gives the probability that z is between 0 and a positive number. This is the most commonly used normal distribution z-table with a positive z-score. So using the z-table, let's find the value of z less than 0. Now there's no need of the table to find the answer once you know that the variable of z takes a value of less than 0 or equal to 0. So first we remember that the area under the curve is 1. And second, the curve is symmetrical about z equals 0. So there's going to be a 50% above chance of z equaling 0 and a 50% below chance of z equaling 0. So chi-square distribution, or x-squared distribution, is with a k-1 degree of freedom in the distribution of the sum of all the squares of k, which are independent standard normal random variables. So some of the characteristics of a chi-square distribution is that this distribution is used during a hypothesis test, and it's most widely used when looking at probability distribution in an inferential statistic. So the formula for a chi-square distribution looks like this. There's a few things that we have to understand. The first one is we're always calculating for chi-square, which is the same as an x-square calculation. We have the sigma, which is standing for chi-square index. Now that is going to be equal to our observed frequency minus our expected frequency. So the FO is our observed and the FE is our expected. Then we're going to take that product and we're going to divide it by the expected frequency. So a t-distribution is most appropriate to be used when the sample size is less than 30, when the population standard deviation is not known, and when the population is approximately normal. Now the t-distribution approaches normality as the sample size increases. So the F distribution is a ratio of two chi-square distributions, and a specific F distribution is denoted by the degrees of freedom for the numerator chi-square and the degrees of freedom for the denominator chi-square. So here's the calculation for F distribution, where an S1 and an S2 is equal to the standard deviations of our two samples. Now if the F calculated is 1, there is no difference within the variance. If S1 is greater than S2, then the numerator should be greater than the denominator. So refer to an F table to find out a critical F distribution that's alpha and degrees of freedom in the sample of the two different processes. This concludes topic 3. I'll see you again in topic 4, collecting and summarizing data.